A hypothesis test is a very formal process. There are 5 steps. The first one is figure out what you're testing. In the previous example with the men, your null hypothesis would be that the mean of men's heights is 69 inches. The alternate hypothesis would be that it's something else. Your null hypothesis always has to contain equals. The alternate hypothesis has to cover the rest of the possibilities. These are the only 2 things that could happen, right? Either the mean is 69 or it's not. Let's do another example of finding the null and alternate hypothesis. So, a veterinarian's journal claims that the mean weight of adult cats is 13 pounds. One vet thinks that the true mean is really more than 13 pounds. So, what are our hypotheses going to be? Note, we don't know what the results of the experiment are yet. You can name your hypotheses before you even know what happened in the actual experiment. In fact, you should. The alternate hypothesis is what this disagreeing person thinks, that the mean is bigger than 13. The null hypothesis is the other case. It's less than or equal to 13. Here, note that she's interested in variation in one particular direction. She doesn't just think the claim is wrong, she thinks the real number is higher. This makes it what's called a one-tailed test. So that's step 1. Step 2, find z, just the way we did in the previous example with the men. And use the table to find the probability. Now, before we can do that, we need the results of an experiment. So, let's say this vet goes out and weighs a bunch of cats and finds their sample mean. She weighs a random sample of 40 cats. She finds a mean weight of 14 pounds and a standard deviation of 7 pounds. Now we have enough information to find z and then find the probability. What's your x bar? 14. Standard deviation is 7, and the number of cats is 40. Remember to put both in parentheses, and it should work out to 0.90. That's our z. Note that it's positive this time. We also had the direction word higher. So we look at the table. 0.90 on the positive side. 0.8159. Because we had the direction word higher, we need to do 1 minus 0.1841. This is your probability, sometimes called your p-value. At this point, we're done doing math, and we have to do thinking. That wasn't really a whole lot of math, was it? The math in hypothesis testing is easy. It's the thinking that'll kill you. So, is this probability small? How do we define a small probability? Usually, small is less than 0.05. So, 0.1841 is definitely bigger than 0.05. Our p-value worked out to be big rather than small. So what does that say about the cats? What were we trying to prove here? Whether the true mean is 13 pounds or bigger. Remember, we had the null hypothesis is that the mean is less than or equal to 13. The alternate hypothesis is that it's bigger. There are two things that you can do. You can reject the null hypothesis or fail to reject the null hypothesis. Those are your two choices. Really, a hypothesis test comes down to a yes or no question. Reject or fail to reject. The way you tell if your p-value is small, you reject. If your p-value is big, you fail to reject. You never accept anything. No acceptance happens here. We are not accepting when we do hypothesis tests. We reject or fail to reject. Now, because your p-value is big, you fail to reject. When you only reject when p is small. Here's how I like to remember that. You know when you open up a can of peas, the peas are like all the same size? But if you buy actual pea pods or grow them, you get the big peas and you also get these little tiny peas. So how did they make the peas in the can all the same size? Well, they must have rejected the small ones. So, you need to reject when the p is small. Reject small p's. Fail to reject big p's. Okay, so this is step 4. Make a decision about your null hypothesis. Reject or fail to reject. And there's one more step. We need to conclude with a sentence about cats, about the original problem. We need to explain what this means. I haven't explained anything, have I? Are you confused? You should be confused right now. This is hard. It's going to take a while for us to get the ideas here. But I will show you the last step, and then we will go on. The last step is to write a sentence. Is the true mean bigger than 13? Have we proved that the true mean is bigger than 13? That's the question. The answer is we didn't. We set out to prove that the mean of 13 was wrong, and we failed. We failed to reject. We didn't find enough evidence. There is not enough evidence to prove cats weigh more than 13 pounds. That doesn't mean 13 pounds is right. It could be 13 pounds is wrong, but we couldn't prove it. So, the 5 steps are: name your hypotheses, find z and use the table. This part is just like Chapter 5. This is exactly what we did when we first studied the normal distribution and this formula. Step 4, you reject or fail to reject based on whether your p is big or small. In the first example, if you'll remember, we found a very small p. So in that case, we would have rejected the null hypothesis. And finally, end with a sentence that actually answers the question posed in the original problem.